In this video, we will be solving triangles using the law of sines, but we will be facing the dreaded side-side angle set of information. The ambiguous case, called such because given two sides and the non-included angle, at a glance, we do not know if you can form a triangle at all. There could be no triangle here. And if there is a triangle, we don't know if there will be one triangle or will there be two. So it is very ambiguous indeed, but fear not, I will walk you through. So as soon as you notice that you have two sides and an angle, here's what you should do. Fearing the ambiguous case, go ahead and draw a horizontal segment, the bottom of a triangle. On the left hand side, draw yourself an angle. Now that'll be the one angle that you were given. So go ahead and put the 47 in there. That makes this angle A. Now across this open side, go ahead and put a dotted line. Alright, that is your swing side. Think of it as a rope that swings from side to side. I make it dotted because we don't know if it'll reach. We don't know if it will only fit here. Will it fit in another place? It's quite variable. It's a swing side, so we make it dotted to show that it's temporary. Now, if this is angle A, then that makes this side A, so this must be the 25 here. Now, the other side, our rigid side, will be the 34. Alright, since this is side B, that makes this angle B, which makes this angle C. So our first job is to decide, can you make a triangle out of this at all? And the way you decide that is by calculating the height. We can find the height by doing the sine of 47. So the sine of 47, that's opposite over hypotenuse, so that's h over 34. Multiplying both sides by 34, that's going to give us 34 sine 47 is equal to the height. Punch this in your calculator real fast. Okay, 34 sine 47. Okay, I am getting 24.866 for the height. Alright, I'll even go ahead and call it 24.9. Alright, it's going to be approximately 24.9. Because what we have to decide is our swing side. Think of it as a rope. Will the rope reach the other side? Is it long enough to reach? And yes, it is. The height is 24.9 approximately, but the rope is 25. So the rope is long enough to reach because it is longer than the height. So we will have at least one triangle. So the question is, could we make two triangles out of this? Now the way you will sometimes get two triangles is if you could take your swing side, you take this rope and swing it inward. And if this rope will also fit in the interior of the triangle, like this, then that'll form another triangle over here, this sort of skinny triangle right here. So the question is, will a rope of length 25 fit inside the triangle in this position? And this time the answer is yes, because the rigid side is 34, then a length of rope that is 25 will fit underneath that. Sometimes the rope is too long and it won't fit inside the triangle, but as long as the rope is shorter than the rigid side, then it'll fit in here and make a second triangle. So what I like to do whenever I see that I'm going to have two triangles is I like to draw a whole another triangle off to the side. So that's what I'm going to do. So here is angle A that I'm about to form again. Okay, so this is like this piece right here that I just drew. And okay, so angle A is doing this type of a thing. Alright, and that would be side C, and here's the rope coming down, the swing side. Now we know that swing side is 25 and angle A is 47, and we know that the rigid side was 34. And so angle B will now be here, and this is angle C. Now we can't have different angles having the same name. Angle B and angle B, this is acute, this is obtuse, they can't be the same name. So what I'm going to do is I'm going to call these, I'm going to put 2's on all of these. So this is going to be angle B2, and this is going to be angle C2. And later when we're finding the side, this will be side C2. And meanwhile, back on the blue triangle, this is angle B1, and this is angle C1, and this will be side C1. Alright, that way we can keep it all straightened out. Alright, for now, let's go ahead and solve the blue triangle. Alright, what are the pieces of information that we're going to need? To solve this triangle, we're going to need the measure of angle B, the measure angle B1, I should say. And we will need the measure of angle C1. And we will need the length of side C1. So we will find these three pieces of information. Alright, let's start with angle B1. Because I'm looking for an angle, I'm going to put angles in the numerator of my law of sines. So I'm going to have sine 47 over 25. Okay, and then I can say the sine of angle B1 over 34. So to get the sine of angle B1 by itself, I need to multiply both sides by 34. That way these 34s will cancel out. So that gives me the sine of angle B1, but I want the actual angle B1. So I need to do the inverse sine of all of this. And that should equal the actual angle B1. So I'm going to put all of this in my calculator, and that'll give me B1. I'm getting 84.066. Okay, now to find the measure of angle C, I can just subtract these two angles from 180. That gives me 48.934. Alright, now I can find the length of side C, once again doing the law of sines. Since I'm looking for sides, this time I'm going to put sides in the top. So I'm going to do 25 over sine 47 this time. And then I will do side C1 over the sine of 48.934. Now to get side C1 by itself, I just need to multiply by sine 48.934 on both sides. That way these will cancel each other out. That leaves side C by itself, so I can put all of this in my calculator now, and that will give me the length of C1. That turns out to be 25.773. So there we have solved the blue triangle. But don't forget, there was another triangle. We had this red triangle that we also have to solve. So let's go ahead and write down our solution box. So we're going to need to find the measure of angle B2 and the measure of angle C2 and the length of side C2 in order to solve this triangle. Okay, let's start with finding this obtuse angle B2, because that's the one thing that's going to be different. We're not going to use the law of sines to find that. You cannot find an obtuse angle using the law of sines, because that requires using the inverse sine at some point to get the angle. Now, inverse sine is only going to give you an acute angle. It will never give you an obtuse angle. But luckily, we don't need the law of sines to find angle B2. Anytime you have this situation where the swing side forms two triangles, the acute angle and the obtuse angle are always going to be supplementary. So I can find angle B2 by subtracting from 180. So I'm just going to take 180 minus B1, and that will give me B2. Alright, this will work every single time that you have two triangles. Okay, so I'm just going to do B2 is equal to 180 minus this 84.066, and that should give me angle B2. 95.394. Okay, to find the measure of angle C2, I could just subtract these two angles from 180. And that is giving me 37.606 degrees. Okay, and that just leaves the finding of side C2. I'm going to use the law of sines for that, but since I'm looking for a side, then I'm going to put my sides in the top this time. Okay, so I'm going to do it this way again. 25 over sine 47, just like I did the last time. Alright, and that should equal side C2 over the sine of angle C2, which is 37 point, hold on, my pen is stalling out here, 0.606. So to get C2 by itself, I need to multiply both sides by sine 37.606 on both sides. That way these will cancel each other out. That'll leave C2 by itself, and so I just need to put all of this in my calculator, and that will give me the length of C2. So I'm coming up with 20.860. I had to round that up. And that's it. We have solved both triangles. We solved for this red triangle and the blue triangle for number 7. Alright, let's keep going and do the same thing for problem number 8. Okay, I see an angle and 2 sides. So right away, I'm going to do this. I'm going to draw a segment, and I'm going to make an angle on the left, and I'm going to make a dotted line representing the swing side. I'm going to put my one angle right in here, and so if this is angle A, that means this is side A, which is 8. I'm going to make the rigid side the other side, which is 13. Since that's side B, this is angle B, which leaves this to be angle C. So before I go any further, I ask myself, will this make a triangle at all? And the way I can tell is by calculating the height of this triangle. I can find the height by calculating the sine of 18. The sine of this angle is opposite over hypotenuse, so that's going to be h over 13. Multiplying both sides by 13 will give me 13 sine 18 for the height. Just going to punch this in my calculator real quick. 13 sine 18, and I am getting 4.017. Okay, so that's approximately 4. So the question is, looking at this swing side as a rope, is this rope long enough to reach? And yes, it is long enough to reach because it is longer than the height, which is only 4. So it will reach the other side. So far that proves that I will have at least one triangle. The question is, will I have 2 triangles? Well, I will have 2 triangles if this rope could swing over and fit on the inside of the triangle like this. Alright, would 8 length of rope fit right here as well? And the answer is yes, because the rigid side here is 13. Because that's longer, then this shorter length of rope will fit inside the triangle. Alright, if this rope had been length 15, then that would be too long and we'd only have one triangle. But we will have 2. So what I recommend when you discover that you have 2 triangles, draw a separate picture for the second triangle. So that's what I'm going to do now. So my second triangle is going to be something like this. Okay, so you see your angle A there, and your 13, and angle C, and your 8 right there. And so what, on this, the blue angle B is out here, but for the red triangle, angle B will be sitting right here. Now I can't really call this angle B since this one is called angle B. So I'm going to call this angle B2 and I will call this C2. And in fact, I'm going to go back and call this angle B1 and C1. And this will be side C1 and this will be side C2. Okay, I forgot the 18, which is not changing. Alright, so we have 2 triangles. Let's go ahead and solve the blue triangle first. Alright, let's go ahead and make our solution box. We are going to need to find the measure of angle B1. We will need to find the measure of angle C1. And we will need to find the length of side C1 to solve this triangle. Alright, our solution box is now ready. Let's go after angle B1. Because I'm going after an angle, I'm going to put my angles in the top for the law of sines. So I'm going to do the sine of angle A, which is sine of 18, over side A, and that should equal the sine of angle B1 over side B1. Alright, now I'm going to multiply by 13 to get the sine of B1 by itself. Alright, so those 13s cancel each other out. That gives me the sine of B1 by itself. But I want the angle B1 all alone. So to get the angle out of this, I need to do the inverse sine of everything. Okay, that should give me angle B1. So I'm just going to go ahead and put this whole thing in my calculator. That turned out to be 30.143 degrees. Now to find angle C, I can just subtract these two from 180. That is 131.857. Now, to find side C, I can just do the law of sines again. But since I'm looking for a side this time, I'm going to put sides in the top. So this time I'm going to do 8 over sine 18 is equal to C1 over the sine of 131.857. To get C1 by itself, I need to multiply both sides by the sine of 131.857. That way these will cancel each other out, and this should give me the length of C1. So go ahead and just put all of this in your calculator at once. That's giving me 19.282. So there we have solved the blue triangle. Now we can move on over and solve the red triangle. So once again, let's form our solution box. We will need the measure of angle B2. We will need the measure of angle C2. And we will need the length of side C2 to solve this triangle. Now, to find the obtuse angle, we cannot use the law of sines, because when you try to do the law of sines, you will wind up doing the inverse sine. An inverse sine will only give you an acute angle. In fact, it would give us the same acute angle that we already got. So that won't help us. But luckily, we know that whenever you have two triangles that are formed by the swing side, the acute angle that you get is supplementary to the obtuse angle that you're going to get. So in other words, if I want to find angle B2, I can just do 180 minus angle B1. Okay, so that's why in order to find angle B2, I'm just going to do 180 minus 30.143. So that turns out to be 149.857. So to find angle C2, I can just subtract these two from 180. So that turns out to be 12.143. Okay, so finally, to find side C2, I can just do the law of sines again. And again, since I'm looking for a side, I'm going to put my sides in the top, in the numerator. Okay, so I'm going to do 8 over sine 18 again. Okay, just like I did last time. And that's going to equal side C2 over the sine of 12.143. Okay, side C2 over the sine of angle C2. So to get side C2 by itself, I just need to multiply both sides by sine of 12.143. That way these will cancel each other out, and that will leave C2 by itself. So just put all of this in your calculator at once. So that is 5.446. And there you have it. We have solved the red triangle and the blue triangle. So we found both solutions for problem number 8. Alright, this will be the last problem on this video. The light from a lighthouse can be seen from an 18-mile radius. A boat is anchored so that it can just see the light from the lighthouse. Alright, so okay, so there's going to be a lighthouse. So let's draw a lighthouse over here somewhere. Okay, there's going to be a bunch of light coming out of this lighthouse. Alright, so there's my lighthouse. Okay, and so there are boats and things, so that means this lighthouse must be in some kind of way over on the shore. Okay, so there's my lighthouse on the shore. Now we've got a boat that is anchored in such a way that it can just barely see the light from the lighthouse. So this boat, I'm going to put it right here. If it can just barely see the light from the lighthouse, it must be 18 miles away. Meanwhile, a second boat is 25 miles from the lighthouse. Alright, so we've got another boat that is 25 miles away. Okay, so don't get too attached to that, but we've got this boat, it's 25 miles away, and it's headed straight for the lighthouse. Okay, making a 44-degree angle with the lighthouse and the first boat. Alright, so in other words, if I complete this triangle, then this is 44 degrees right here. Now there's more to the story, but we're going to need to know what these angles are to find anything else that we need to know. So let's go ahead and figure out what these angles are right now, and then we'll go ahead and analyze the rest of the story. I'm going to call this angle B for boat, and I'm going to call this angle L for lighthouse. So let's see, which one of these angles can I find? I should be able to find angle B first, because that's across from a side that I know. So I'm going to go ahead and use the law of sines to find this. So let's see. So I'm finding an angle, so I'm going to put my angles in the numerator. So if I go sine of 44 degrees over 18 miles, that should equal the sine of angle B over 25. So I'm just going to solve this for angle B by multiplying both sides by 25. So these 25s are going to cancel each other out. And this gives me the sine of angle B, but I don't want the sine of angle B, I want angle B itself. So to get that, I'm going to need the inverse sine of all of this. And that should give me angle B. So I'm just going to put all this in my calculator. So I'm getting 74.753. That's angle B. Alright, now just in case we need it, let's go ahead and find angle L. We can find that very easily by subtracting these two from 180. So that's going to give us 61.247. So angle L here is 61.247. Okay, now we better stop and analyze the rest of the story. Okay, because in the end we want to find the distance between the two boats when the second boat enters the radius of the lighthouse. So right now the boat is, well, at this snapshot where I drew this triangle, the boat is, the second boat is 25 miles away from the lighthouse. But the radius of the light from the lighthouse is only 18. Okay, so this is the radius of the light from the lighthouse, alright, which is the same as this, alright, because the first boat was just barely able to see the light, so it was at a distance of 18. So now we want to know what will be the distance between the two boats when this boat, the second boat, moves closer to the lighthouse until it's 18 miles away. So things have changed at this point. The boat has moved closer and now it's here. Alright, now that doesn't change the angles that we found from the first snapshot, so we can still use them if we need to. But the actual distance that we're trying to find, though, is this distance right here. Okay, the distance between the two boats at the point when the second boat is now 18 miles from the lighthouse. So actually this is going to be an isosceles triangle, and with 61.247 at the vertex angle. To avoid confusion, I'm going to go ahead and erase angle B here, which is kind of in the way, because I don't want you to think that the angle I'm about to put in here is angle B anymore. Angle B was this wider angle in the purple triangle. But now we're focusing on this blue triangle. In fact, maybe I'll even make this 18 blue, so it all ties in together. So on this blue triangle, I have this isosceles triangle because the two 18s, and that means these base angles are going to be equal. So look, what I need to do is I can find out what these angles are right now by subtracting this from 180 and dividing that in 2 because the base angles are equal. So that's what I'm going to do. I'm going to subtract this from 180, So I'm doing 180. Okay, I'm doing 180 minus 61.247. And I'm getting 118.753. But now I'm going to divide that by 2. Alright, so I can separate it between these two angles. So if I do divide it by 2, then now I'm getting 59.377. Okay, so each one of these angles is 59.377. Okay, so now I should be able to do the law of sines to find this side. Okay, because I'm looking for a side, I'm going to put sides in the top of my law of sines. Okay, so I can do 18, for example. Alright, that's a side. So I'm doing 18 over the sine of 59.377. And that should equal x, alright, because that's another side, over the sine of the opposite angle. So x over the sine of 61.247. Okay, so to get this x by itself, I need to multiply both sides by the sine of 61.247. So these are going to cancel each other out, and this is going to give me the distance between the two boats that I was looking for. So I'm just going to put all of this in my calculator all at once, and that should be the answer. So that is 18.338 miles.